Hello, everyone. In today's session, we're going to talk about reactive stores that you can use within your front-end architectures if you're building Angular, React, or Next.js spas. This is a solution to a problem that every single web developer has run into, which is how do you manage where your data is changed and how those changes are propagated to views so they can be re-rendered, or how do views get notified that the changes have been made? And how do you share that data between multiple views? So using reactive stores is the solution and the architecture pattern that we're going to talk about today. Those of you who may have heard about NGRX or the component store or MobX, Recoil, and others. But today we're going to be talking about Zustand for using our reactive stores. So I'm excited to introduce a guest to our session today. I'd like to introduce Jason Rusch, who is a senior engineer fluent in Angular and React and Next.js. Hey, Jason, welcome.
Thank you, Thomas.
As I mentioned, today we're going to be building reactive stores using Zustand. Zustand is an open source library available on GitHub. And while the API at first feels a little bit odd, once you become familiar with the way it's supposed to be used, it's incredibly intuitive and incredibly powerful to quickly build stores that you can share data between multiple components, and that you can centralize and isolate a lot of your business code outside of the UI layer. So let's take a look at a MovieSearch application that we've already created that's using a Redux-like pattern. And it's this application that we want to actually rework to use reactive stores with Zustand. So here is the application. It loads movies from a remote movie service. And if I search, for example, snakes or cats, I can also do a filter where I can say, show me all movies that have the word cats in it, right? Or if I want to do owner. And of course, it not only filters out only the movies that have the word owner in either the description or the title, but it even highlights that. And if I clear this out, then we get back our movies. So this is the application that we have existing code for, and we want to rework it to use a Zustand store. Before we do that, let's go back to something I mentioned a little bit earlier. The classic problem that every single web developer runs into, myself included, is that it's super easy to create UI components and put your business logic in those components. So let's say I have a store that I want to show a list of movie cards. I could easily put the data service inside my card list component and make a call to that data service directly. The problem with that is that I'm now starting the dangerous road. Right? I'm now starting to put business logic inside my UI component. And for simple little applications, you may say, no, that's not a big deal. But as you start wanting to share that data between different views, and this happens quite a lot and becomes problematic in React especially, but even in Angular, as you start wanting to share that data between views, then the issue is, well, where do you move that business logic from? And you really should be moving it into something we call the business layer, which we have highlighted as sort of outlined in gray here. So we want to move it outside of the UI layer and put it into the business layer. And in fact, what we really want is we want to consider that the business layer is a little bit like a black box. There's a whole bunch of hidden components in there doing things that we shouldn't, from the UI layer, we shouldn't have to worry about, right? It's just doing what it needs to do, and then it's giving us typically the data. But what it really needs to be doing, actually, is giving us something called a view model. Now, this is a concept that took me a little while to understand when I was first introduced to it. And I kept thinking a view model is just data. It's just some object that has the data in it. But a view model is more than that. A view model is not only the data, but it's an API. It's a set of one or more functions that can be used in the UI layer to call back basically to the business layer, but the UI layer doesn't know about the complexities of the business layer. It just makes a function call that's on the view model. So it's the business layer that is responsible somehow to publish that view model. And that view model does two things, right? The data that's inside the view model, think of it as a current snapshot of the data, is actually used to render things in the UI. And when the user interacts with the UI, or maybe needs to do extra things, maybe initialization, then it will actually make calls through the view model's API back to some hidden layer. Now, this is especially important because then that means that the UI layer is super simple. It's only focused on rendering data and interacting with the user, and it's focused especially on layout, right, and styling of the UI and user experience. All the details about how the data is cached or stored, how it's accessed, when it's loaded, how it changes, all those details are hidden somewhere down in the business layer. And whenever those aspects change, then a view model will come back out and the UI can re-render. So it's the view model that is the glue, the metaphorical glue between the UI layer and the business layer. All right, so that's a best practice and something I highly recommend that everyone do. So how does that relate to Zustand? Well, remember I said Zustand has this powerful approach where you can create a store that you can then use within your UI. But it's slightly different than that. So with Zustand, you actually create your view model inside Zustand. And then Zustand publishes that view model out to the outside world, and then you can use it in your UI layer. And you can make calls back from your UI layer right back into your API. And that API can do anything it needs to do. It could talk to the data service, could do other things. And when it makes changes to the data, it tells Zustand, hey, here is the Zustand Store, here is some new data that I need to merge into my current view model. And Zustand is responsible for merging in those changes and then notifying the outside world that the view model has now updated and there's a new snapshot of the view model. So it's the Zustand Store that is managing the data changes and the notifications, but it's our view model that has all the core business, custom business logic that we want to create. Jason, I think we should jump into code, don't you?
I do.
All right, so let's jump into the code, and we'll actually take a look back at that application, the MovieSearch application, and we'll see where we can get started. Our application here is actually using a movie view model. All right, great. And in fact, it's using an observable to the movie view model. And if we look over here, there's a header bar component, and this header bar component has a whole bunch of options, right, that we can do our search and our filtering for. And in fact, we initialize the form fields with the current values from the view model. So search by and filter by are used from the view model to assign and initialize those fields in the header bar. And likewise, when the user does things inside the header bar area, maybe he's typing or he hits enter to load a new set of movies, or he's changing the filter, then that event comes out of the header bar and it goes right through the view model to the update filter or the clear filter or the load movies. Now, from the UI's perspective, we don't actually know how load movies is working or update filter is working or even clear filter, right? This is the beauty of the view model, is that it's simple calls. We're making calls to the view model, and that is actually doing something else. Actually, under the hood, it's actually proxying those calls down into some custom code. So we also have our movie card list, which is, again, using the view model, and it's using the filtered movies list to actually render all the movies that are currently available. So the most important thing about this code here is that this code actually defines, from the UI layer, it defines, hey, this is the data that I need. These are the methods that I want to use. So if you're going to create a view model and give me a view model, these are the things that I need. And that's the essence of a view model, is that the view model is created and it's custom to the UI that's using it. The view model can be used by several UI components, but it has an API and data that's specific to those components. Okay, that's cool. So we can use that approach that the UI helps us define the view model, and now we can go into this idea of a movie store, which we have here, and we can start building out and creating a Zustand store that will publish this view model for us. So Jason, I cheated a little bit here, and I created a shell for us, all right? So here is a method that I call build Zustand store. And it's going to return some structure, some data object that has inside of it that's managing a movie view model. And inside this method right here, I actually have another function called build view model. All right. When you're using Zustand, you're going to import from Zustand vanilla. So Zustand actually has support for use within React and hooks, and it also has support or even Angular. So here we have an Angular application, and we want to use the non-React version of the code. So that's why we're importing from vanilla. So we have this method called create, and create's essentially going to create a store API for us. All right. So here we say create, hey Zustand, create a store instance. And here is our factory function that will build an instance of our view model. All right. The really interesting thing about this factory function is, notice here's the factory function here, right here, is that when it calls that function, Zustand passes into that function three very important arguments. It passes in a setter function, a get function, and a store function. The one that most developers will be using is the setter function. In your code, when you want to call set, you're essentially going to be making an internal call to tell Zustand, hey, I'm setting some data. I'm changing the view model. And internally, Zustand is going to figure out how to merge your changes into the rest of the view model, because you could do partial changes if you wanted to. And then after your changes are done, it will notify any external subscribers, hey, the view model's changed. So we don't have to worry about that at all. That's incredibly powerful. So this is the code base we want to start with. And Jason is going to actually start going through this and building this out based on the API that we want. And the first thing we should do, now that we've seen this, notice, by the way, it's returning this here. It's returning data and the API. This is something else that I really wanted to stress. This is a pattern that I highly recommend. If you're building a view model, then remember the view model has two parts. It has data and an API. So why not in our factory function organize the same things using that approach, right? So we'll create an instance of our data, an initial set of our data values, and then we're going to create our API that will be part of the view model. Now, if I come over to the models here, I can see that I have a movie API already defined as an interface, right? I have a clear filter, a load movies, and an update filter. And these are the same methods and functions that are going to be used in the UI, aren't they? Remember? We also have movie state. So I have, this is state that's going to be published and going out to the view model, which is a list of all movies, what's the current search by value, what's the filter by value, and what's the filtered movies. Now, for different applications, of course, they're going to have completely different state variables, right? And they'll probably have totally different API methods. But this pattern, this idea of using a movie API or an API interface and a state interface is still the same. And then we'll have an initializer here, a function, which just returns back an initial default set of the movie state. So notice, by default, we're searching for dogs. I just put this in here to demonstrate that the view model, once it's initially used at the UI layer, it will set that field to dogs. All right, so if we come back to here. So Jason, why don't you, if you don't mind, work through how you want to start fixing this build view model function here. Jason, why don't we go ahead and start building out fixing our build view model to work correctly? And I would suggest that first we look at line 22 and actually fix how we're initializing our movie state.
Great. Yeah, so like you said, we have an init state function that we can already call. And that should give us back our initial data.
Awesome, awesome. And then, so now we have the data part that's been initialized. That's pretty easy because we already had that code written. Now what else do we need to do next to get the build Zustand store to work correctly?
Well, we've got to define our API.
Okay, and what are our methods of what API methods do we need?
We need the load movies.
Okay.
We need the update movie, or update filter, I should say. And we need the clear filter.
Awesome. Okay. Let's work our way up from the bottom there. So what do we need to do with clear filter?
Well, clear filter should just clear the stores filter. We can do that by using the set function.
Right.
And do a partial update to just set the filter to an empty string.
Right. So the cool thing here is that when we call set, this is a method that's given to this function, this factory function it's given to us from Zustand, the engine. And set actually takes two parts. You can either pass in a partial view model, in this case, so a partial data structure, or you could pass in a function, and that set method would call your function with the current snapshot of the current state. And our state, by the way, Zustand calls it a state. Here we're calling it a movie view model because we're being explicit in our intention that it's not just data or state, but it's also an API. So when Zustand says state, I'm saying view model. They're equivalent in this scenario. So I could have done something like this. I could have said, all right, just pass in the current state, and that is going to be a movie view model, right? And something like that. And then I could have said, just like this, state filter, I could have done it that way. Code, there we go. So that one will work, but the version that you wrote, Jason, I thought was much nicer because it was very terse, right? It was very clean. We didn't need to do anything extra. Sometimes we'll want to use this approach when we need extra information that's in the current state. All right, and we'll see this in just a minute. So let's go back to your version that you had a moment ago, this one here. That looks pretty good. What do we need to do next?
Yeah, so I think clear filter is done. So we can move up to our update filter.
And let's do this one with the function approach.
Okay. So like you said, pass in a function, give us our state back. And then inside here, we can do state.filterBy and have that equal our filter by the parameter that we pass in.
That's right. Notice though that, go ahead.
Not sure if we need to return our state back, do we?
I believe we do.
Okay.
If we were using Immer, which we had talked about in a previous session, Immer has some pretty nice features to that, but we're not using Immer right now. So in this case, if we modified the state, I believe we have to return it back. All right, so now let's go ahead and let's do the load movies.
Sounds good. So load movies, what we got to do is get our data somehow. And currently we don't have a way to get our data from an API call.
Well, we do have that API service right here that we can inject into the movies data service. So we could pass that in as an argument to line 19.
Yeah, that makes sense.
I think it's, there you go.
All right, so now I have an API to call. So what I can do is get my movies from there.
Mm-hmm.
And I think it's the search movies endpoint. And we'll take our search by that we got on our page.
Right. Now, so notice a couple things here. So you started to use this and then you got rid of it, which is good. Because we can't use this dot because we're not in a class instance, right? We're just in a regular function, a standalone function. We'll fix that in a bit. But right now, so now you're calling movies dot search movies. That returns to us what though?
That returns our all of our movies as an
Right,
observable.
but it does as an observable, right? So what we could do is we could do a little bit of elegance here. So let's make our load movies async. Okay, and then we can do an await on the call there. And then finally, this is an observable, so we can't call await on observable. And we could use in RxJS 6.x, we could have used a toPromise, but I think that's been deprecated in 7.x, and we're using RxJS 7.5. So we should probably do something a little different than that, right? Well, we could use first value from, right?
That's right.
Does code, did it work for you? Yeah, it did work. Okay, cool.
Work that.
And all right, so now we have our all movies. Now what do we need to do next?
All right, so now we need to store that in our state. And we can use that partial to just use the key and the value of all movies.
Mm-hmm. We should also probably, what else should we be saving here though? Just to be clear, should we be saving the search by?
Yes.
And why do we need to save that search by versus the one that's, because we already have a value inside the engine, right? Inside our view model.
We want to save that one to the store so that when our VM view model is returned from the store, it would have the updated value.
Right, because this list of movies here is being loaded based on the current value of this search by, not on the current value that's inside the view model.
Right.
Right? So that's one of the reasons we have to save the search by. We don't care about the page number right now, because in this scenario, our application doesn't have paginated features. So we just default to load the first page. But that second argument there is there in case we ever wanted to load others, right? And in fact, to be more clear, we could say something like this. We could say equals 1, something like that.
Yeah.
Okay, so now this is looking pretty good. Maybe should we try to run it and see if it works for us?
Yeah, let's do it.
Okay. Well, before we do that, we're still missing a couple things, right? So in our app component here, we have this view model here, but it's an observable. And how does it get that observable? So in Angular, the way we pass services around is we use Angular dependency injection, right? So we need to inject inside the constructor some service. And in fact, what we want to inject is a movie store. Now, we have here a function that builds a store API instance right here. And we'll talk about that in just a moment. But what we also need is we need a class that can be registered with Angular in the modules, and as a service that can be injected into the UI component. So let's go ahead and do that, and I'll just create the shell for us here, just to get us started, injectable. Okay, and let's just provide this in, root. There we go. And let's just export class movie store, just like that. All right. And we know that this movie store, if we look back here in our component, it needs an observable of a view model. So our store absolutely needs to have an observable of a view model. So let's do that. Sorry. There we go. What's this? Cool. And what else do we need here?
We need a constructor.
We do. So you want to go ahead and do that?
Sure.
Okay, are we passing anything into the constructor?
We are. We're going to pass in our movies data service, right?
Right, because we're using this movie's data service here. But remember, Angular is actually managing this as a service. It provides it as a service instance. But it only gives those via dependency injection in the constructor if you're using Angular 14. In Angular 15, there's an inject method, but we're not using Angular 15 here just yet. So we can inject in the movie's data service here. That's pretty cool. So now how do we get our store, right? So inside the constructor, let's just call that method build Zustand Store. Okay, awesome. So what we're seeing here, by the way, is that Zustand lets us define all the details about our view model, and then it manages changes to the view model, and then also internally it will manage notifications to observers that the view model's changed. But we've had to create a movie store wrapper so we can actually use it pretty easily and give it services, runtime services that are needed, right? So this wrapper is just a simple wrapper. The complexity of the store details, though, the view model, is all managed down in here. So that's pretty cool. It's a separation of concerns, right? This store, our view model, knows how to make a call to a service, knows what to do with update filter and clear filter. And it's this guy that just knows only how to create an instance of that service, right? But there's something else that's missing here. Now we have this store, but if I look at this API here, so let's be more explicit and call this store API right here. And this is a movie view model, all right? If I click on this here and I look at it, I can see that it has just 4 methods: set state, get state, subscribe, and destroy. Notice I don't really have access to the view model. Well, I do. I could say get state, right? And that would give me a snapshot, the current snapshot of the current values of that view model. But again, that's the key word. It's a snapshot. So that's not quite what I want. I want to be notified anytime the view model changes. So that's pretty cool. I can use a subscribe method. So let's go ahead and do that. After here, let's go ahead and use that method. So we'll say, you want to go ahead and set that up for us, Jason?
Sure thing. So
we could say store.subscribe, right?
Yeah.
And what it wants to know is it's going to, the function that it needs is a function that will take the current view model VM. So whenever the VM changes, it will call this function with the current VM, all right? And then we need to do something with that current VM, right?
Right.
Okay, so now we have a way to listen to the changes to the view model that's inside the store, but somehow we need to propagate those out to this stream here, right?
Right.
So what we can do is we can create an observable that internally is using store.subscribe. And we can assign the observable to the view model stream.
You want me to go ahead and do that?
Would you mind?
Not at all.
Now this code here looks initially a little bit weird, I bet, to probably most people, right? Because, yep. And there we go. In fact, if we save it, there we go. So it's funny because we have a store.subscribe and then the observable has a subscriber, right? This subscriber is a subscriber that knows that of anyone in the outside world who's subscribing to the stream. This subscribe is essentially allowing us to attach a callback, a change callback, or a notification callback when the view model changes. So we need to hook this callback up to the subscriber. So we can do that pretty easily. How would we do that, Jason? Oh, it's right there. Code Pilot did it for us. So we could just do just like that, and we could say subscriber.next. So that's pretty cool. We've said when the store announces to the outside world that the view model's changed, just tell through the stream any subscribers that here is the new view model. Okay. Now, if we come over here, we can just actually add this guy in, right? So now we could say store. This would be a movies store. And in fact, what I want to make sure is that, all right, so now that should be working. And now if I come over here, I can inject this guy in. Sorry. Fat fingering here. Cool. And then I can say this.vm dollar is equal to the store VM. So this store, by the way, maybe I should call it, to be clear, maybe I should call it a service, right? Because we call it a movie store, but if we really look inside of it, it's not actually the real store. Here's the real store. It's just a wrapper to it. But this allows us to use Zustand and then hook it up to work really well inside Angular here. And now we have an observable. And over here, we can use the async pipe to watch that, to subscribe to that observable. So let's see if this will run for us, okay? So now I'm going to do ng-serve. Oh, that's interesting. Didn't seem to work. If I come over to network, okay, so it's not even making a call out, is it? Ah, I think we forgot to do something. We told Zustand how to set up the store. No one's made a call to load movies. And inside here, we should probably call load movies.
Yes.
So how will we do that?
Oh, well, we need to get our current state or VM from the store.
Correct. So go for it.
All right. And we have that get state that gives us that snapshot.
Mm-hmm.
And
now
in fact, we don't even need the VM. We can just destructure it to be.
Oh, that's a nice technique.
What are we getting? We're getting the API. Load movies.
Right. And load movies, it needs something, doesn't it? It needs a search by. So we should probably grab that too.
Yep, it does. All right. And then we go ahead and call it. Pass in that search by, and page 1 is default, so we don't even need that.
All right. So let's try to save this here. And let's see. Oh, look at that. Now it's loading the movies. But it's, wait a minute, it's not actually showing the movies, even though it successfully loaded them. What's going on there? Ah, the view, if I come over to the code here in the component, it's using filtered movies. So if we go back to our store down here, we got all the movies, but we never did anything with filtered movies, did we?
That's right.
So let's go ahead and fix that. We'll fix it here. When we start finding bugs, guess what? We're not fixing the bugs in the UI components. We're fixing them down in our business layer. And in fact, we are fixing them right here in our APIs calls and down where our view model is being constructed and managed. So let's go ahead and fix, how would we fix that?
Well, I think we'll need to get our filtered movies.
So more than likely, since we need filtered movies, then probably what we should do is maybe just use the set with a function call instead of a partial data object. So maybe on line 50, we should pass in a function. Yep. Now, and then we probably should set the search by. Right?
Mm-hmm.
And now we have to set the filter too, don't we? I mean, the filtered movies. But there's a really cool method that we have available, which is compute matched movies. So if we copy that and bring it down here, we could then do something like this. We could say state.filtered movies is equal to compute matched movies, and it wants a partial state. Well, guess what? We've already set this all movies here in the search by. So let's just pass in the state here. So one of the things we should probably do here is we can just do this. This is a movie item array. So we just had to type our REST call, right? Our HTTP client call, and now it works. And now this is pretty cool. Now we've set filtered movies, and that filter logic, by the way, is down in this filters module here, which is really cool because we can test that totally separate, but we can use it easily here, right? Now if we go back and I refresh, okay, guess what? What did we forget? Why is this not working?
Forgot to return it.
Ah, go. You want to do that for us?
Sure.
That's really interesting that it's not reloading. So this is interesting, right? The UI is not re-rendering. It's not showing our filtered movies. Why is that? Well, there's a slight gotcha when you use this function here to actually update the state. You can't mutate the state itself. You actually have to return a new state object. Otherwise, Zustand just compares references to the reference values and it says, hey, that's the same object that I passed into you. Nothing's changed. So if we create a new object and we return that, now we're going to see, and let's clear this out here. Okay, now it's showing our movies, right? This is pretty cool. We have something else, and if we do this, by the way, if we change it to cats, that's working great. Let's do a search for Spike. Oh, that's interesting. Nothing has happened here with our UI. So we're still missing, something's going wrong with our state still. Any idea what's going wrong here now, Jason? If we change our filter, why isn't our card list updating?
Same reason, I think. We don't have our filtered movies in the update filter.
Okay, so let's go ahead and fix that too, shall we?
Sure. So same thing you did here. We will just do that same thing here and change this to return a modified state.
Awesome. And we should probably do something similar with clear filter too, right?
Yes. So clear filter is going to want our filtered movies to be our all movies.
Okay.
To clear out any filtering. So we can do the same thing here, but this is going to be blank, and this is just going to be all movies.
Okay, now if we come over here, and all I do is search for, let's go to cats again. And let's look for Spike. And there's Spike. So now it's working great. The problem with this is two things. First, what we've just seen is that when we make changes to some variables, we have to remember to update other state variables appropriately. And it can get tricky. And in fact, if we look back at our interface here, we can see that we have our filtered movies here. So anytime all movies changes or filter by changes, we need to update the filtered movies. Because we're doing our filtering in memory. We're not actually doing our filtering at the server, right? And we're doing our searching at the server, but we're doing our filter at the client. And so that creates some real trickiness that we have to remember to do. And that's actually can be problematic. And in fact, this falls into the realm of what we talk, what's called computed properties, or sometimes known as derived properties. Just like you might have, and I'll just type it down here for a moment. So now that we know that filters movie is actually a computed property, why don't we make some changes to our code so we can account for this, right? What we want to do is we'd like to use Zustand, but we'd like to use it in a way that the computed properties are handled for us automatically. Like we don't have to write any code other than once, any code to manage state changes like this. All right. So let's do this. Let's come down here and let's create another interface, which is movie computed state. And it looks like I don't want that there. That we're defining it here. Okay. And this one here is just going to be this guy down here. So we're only going to have one property that's computed, but it's the filtered movies. All right, that's cool. So now we can remove it from init state because we're not initializing it. We never actually assign it a value explicitly. It's always calculated when any of the other state changes. All right. So there's that. Now, that's cool because our movie state here and our movie API are unchanged, but our movie view model now needs to be a union of not only the movie state and the movie API, but also the computed state. Because the outside world is using that property, filtered movies, right? So here's our movie API. Here's our state. So these are things that we can change, but this thing is always going to be calculated on the fly. So how do we do that? Let's come back to the store. All right. And let's create a function here. And what we're going to do is create another function right up above. And we're just going to call this const build computed. Okay. All right. And that's going to take some movie state, and it's going to return not the movie view model, but movie computed state. All right. And it's going to do something like this. It's going to call compute matched movies again. And in fact, what I can do here is I can use destructuring, and I can say the only thing I'm really interested in is all movies and the filter by. Do something like that, right? Mm-hmm. Now, I could even be smarter than that, and I could just say, all right, I'll just pass in the state, and down here, I'll pass in the state. Okay. So that's our, let's do this so for clarity. So now we have our build computed state, right? And we also have our build, and no, this is no longer build view model, right? This is really a build store function, right? Because it's just building the store, all right? But it's building the store, which is a, well, actually in this case, there's two ways we can approach this, but the easiest one for now is to do the following. We're just going to call this, we'll call it a build store function. It's going to still return the view model, all right? But we're going to fix this in just a moment. What we want to do, we're passing in a set function, but that's the standard set function. We want to actually intercept that function, change it. So when anyone calls set, whether we call it internal or the outside world calls set state, whenever they call set, then the view model state's going to change. We want to then automatically also compute the computed state. So what we can do is we can say set is equal to compute with, and we're going to pass in the store here, and we're going to pass that in. All right. Okay, so the problem with compute with is that it's complaining about is it needs to know what is the data type that's going to be returned. So we can just put this in here like this, and now we're saying compute with it's going to give us a set function back out, but it's a set function that knows how to deal with a movie view model. All right. So coming out of the set will be a movie view model, which is good because our build store function says it's going to return a store that's managing a movie view model. So that's consistent. This is a pretty cool approach here because now we can do some cleanup that you may like a lot, Jason. So first off, we can get rid of all this. Now we can use a partial and we can say all movies and search by. Because remember, as soon as set is called, under the hood with this it's now as a new version of set. Under the hood, it's going to actually not only save all movies and search by, but it's first going to compute the filtered movies and also add that in as part of the set process. So it handles it for us sort of magically, right? And the same here with the set here. We can call here, call set filter by, right? It's pretty simple. And this one here, when we call this one, we can just say filter by now as an empty string here, right? So these are significantly cleaned up and easier to understand. But we still have one little problem here. This structure that's coming out is the movie state and the movie API, but it's missing the computed API too. So the only thing we have to do there is actually do the following. We can just, and this is the initial data, by the way, so we can just call here like that. Okay. And now I can just call this here, and we could still call it build view model, right? If we want to. So now we have our code is significantly cleaned up because we're using a special function that everyone can see here in the utils. I'm not going to open that up right now, but it's already prepared and it lets you can be reused for any view model that has computed properties. You just have to tell it what is the view model type that is going to be used or returned back out. That's all. So we pass in the store and we pass in a function that actually knows how to do to compute the computed properties, which is right here. In this case, it's only computing one property, and this property here is being merged in with the view model state whenever you call set. Let's see if this is building back for us here. This is pretty cool. And if I do, let's do 1. That's pretty nice. If I escape. So this is the way we would use a computed properties with Zustand. And it's a little bit more complicated, right? If you weren't using view computed properties. But remember, the code that we had before, Jason, when you were actually manually trying to set the filtered movies, you did it in load movies, but then we forgot to do it in update. And then we put it in update, but we almost forgot to put it in clear filter. And so that actually highlights the fact that if you have computed properties and you're trying to manually manage those, it's really easy to forget to do it at every place that you need to. So doing it manually is not the right solution. Doing it automatically is the right solution. So with Zustand, you can easily do this. Now, I want to show you one other really cool feature of Zustand. Zustand has something called middleware, where you can add extra things that need to happen after the state's changed, but before the view model changes are emitted to the outside world. So what if we wanted to add extra middleware where we wanted to say, listen, I want to save my data in a local session, like in the local storage. So anytime the view model changes state, I want to save it in local storage. That's one thing we want to do. The other thing I might want to do is, and by the way, not only do I want to save it there, but next time I start back up, I want to restore it from local storage and use it and initialize. I don't want it to initialize with this, which is the blank initialization, but I want the store to initialize with whatever's in the local storage, right? So that's pretty cool. And then what if I wanted to use immer also, where anything coming, my view model should be immutable. This means that when the UI layer components are trying to do things with it, they can't make changes to the data directly. We saw in a previous session how dangerous it is to emit data that's immutable, right? That anyone can make changes to it. The problem is if you make changes to mutable data, how do people that are sharing that data get notified that the data is changed? So by making it immutable and by using stores and observables, we solve all those problems. So how would we do that here? So let's just come in here. So the first thing we would do is Zustand supports this idea that you can call a create without a factory function. And then you can come in here and you could say, all right, I want to use immer, right? And now coming out is the middleware will run. It first will build the view model, and then immer will actually watch it. Anytime the view model changes, will actually make it immutable. Okay? So this is middleware that I'm attaching. And notice, by the way, I can't emphasize this enough. This function only gets called one time. It gets called one time to create the initial view model. But then after that, when you call your load movies and all that and all these things, this function's never called again. So this process here registers the view model to run, right? And then immer sort of wraps it. Basically, it says, hey, when you get ready to call set, I want to be notified, and then I'm going to make the data immutable, and then I'm going to actually, instead of setting it with your data, I'm going to set it with your data that's now been marked as read-only. So it's sort of like an extra interceptor or wrapper. And all these things are prepared ahead of time before the function's actually called. All right? So what if we wanted to persist it? I could also persist, right? This here. And this is another right here. So what I can do is in the right here, I should be able to call persist right there. So, sorry, it's not out of vanilla, it's from, and this is a little bit weird, so I'm glad we ran into this here, but we would want to import this from Zustand /middleware. Now you may ask, why are we importing persist from middleware? But why do we have to do this special one here? Why do we have to explicitly say, don't import immer from middleware? Because it's actually not. It's not exported. It's not made public from here, right? It says here, it doesn't have an exported member, immer. So that can feel really weird at first, right? And the reason they did that is because immer, this function, actually under the hood is using the immer.js library. And if you aren't using the immer function, then they don't want to have the code to have a compile time and build runtime dependency on that immer.js code. So only if you explicitly import it are you saying that you have a dependency on that code then. So that's why they did that, right? So now if I come back here, this looks pretty good, but I have a couple things that are missing here. So first, I probably should give this a name. This is the name of the local storage. What's the key that it should be saved under? So let's call it MovieSearch. All right. So what we're saying is immer doesn't need a name, but the persist needs. So here's what immer doing its work. Persist needs the name, right? And so let's run this now, see if it's still running. Okay. The easy way to check this is let's bring this over here. Let's come over to cats, and let's do a search for New York. And let's come over to and look at our session storage. All right. This over here so everyone can see it. So here is the MovieSearch, cats, and new, right? And as soon as I make changes to here, it's going to give me a new one. And here's the state, which is cats, and the filter by is now an empty string. And if come back to new for a moment. If I just refresh this entire application now, it restored automatically from local storage the settings, cats and new. So what that meant was, what's happening is that when the Zustand Store is initializing, that middleware runs and says, hey, is there anything in the the local storage? Yes. It resets the view model to use the current search by term and the current filter. That makes the call out to the server. And then it applies the computed properties to show you this here. And it's all being done with this simple middleware right here. It's incredibly powerful. Right? And we haven't proven that the data is immutable, but you could also do that. Another really cool thing is you could actually add Redux DevTools. Right? So I could say, sorry, it's DevTools. So this is another middleware. And this one, let's give it its own name too. Let's call, because we want to know what it's going to be named in the, oops, let's add a comma here. Now if I come back, all right, and I'm running this here, let's refresh it just to be safe. If I come over here and look at the DevTools, and I can look at the state, and there is my cats and my new. It shows up in the DevTools. So I can actually watch what's going on here. And so let's see if I did this here and I called dogs, right? And if I come back up to the Redux DevTools, now it says dogs and new. If I replay it back, cats and new. So I can actually, from the DevTools, make changes to the state, which updates Zustand's state, which updates the view model, which then re-emits from the store a new view model snapshot, which then goes through the observable stream and comes to the UI.
Amazing.
So it's almost like I'm remote controlling my application just through state changes. And all those features, immutable data was handled through this middleware, persist is handled through this middleware, and DevTools is handled through this middleware. And we have computed properties handled here. Pretty amazing, isn't it?
Very.
The thing that I love about Zustand is this idea that I can call create a store API that will handle this view model. And it's in this function here, this factory function, that I can define my view model. This little bit of code publishes a view model. And if we go back to our, this guy here, so that code is the view model. And the Zustand Store emits notifications that it's changed, and then that goes through the movie store and through the stream. And the UI then is using that view model observable. And those changes coming that when you make changes to the filter or the search by, goes right to those API methods, which are right here. Extremely self-contained, very easy to add extra state properties, very easy to add extra API methods, very easy to maintain and to test. Any questions, Jason, before we close today's session?
No, this is amazing stuff. Really, really good.
In your experience, how would this transform the way developers write code?
Well, yeah, I mean, I could see the view components being very clean, only interacting with the view model, and then allowing the backend to handle all the logic or the store. And then the store also can then be tested and maintained separately. And yeah, just overall, it seems like it's better to be able to maintain, test, and read what's going on.
Right. And the other really cool thing about this approach is this data is centralized and it can be shared with multiple components simultaneous. And anytime the view model changes, all those components, if they're watching the store, can get notified at the same time. There's no worries that one component will be out of sync with another one with respect to the data that they're trying to render. Right. So that's the other beautiful thing. Now, the thing that I haven't shown you is, well, what about React? This is Angular. Well, what about React? Right? So let me show you another one, which is the Zustand Store using a React application. So here in this application, if I come over to here, and let's just minimize this here. So we have two components. right? We have a dashboard and it's just rendering two components. It's rendering a welcome and a welcome with a selector. So here's our welcome component and here's our welcome with a selector, all right? And in this case, I'm using a Zustand Store to manage the language setting, a UUID, and any other parameters that I might want to in the future, right? But there's a whole bunch of things going on here that are really interesting. So first off, let's go take a look at the store. So first off, the store is calling create store. So remember, in our Angular version, we had a method called create, but that's because it was using the vanilla version. With React, there's some extra power that's available for server-side and client-side rendering. So we're going to use this method called create store. Okay. The factory function is very similar to what we saw before, right? So here's our factory function, and now we're only passing in set, right? Set state, update the state. We don't need the get, and we don't need the store. We're just passing in these. And here we have our data, or our state, and then here's our API, add, remove, and clear it all. Notice it's a little bit confusing here because, right, I don't isolate it with where I assign it to an API variable, but I could. And so the thing is I wanted to create this store so any number of UI components could use the store and render what they're specifically interested in, all right? Notice, by the way, we're also using a middleware here, Immer, Persist, and DevTools. Very similar type approach. It's just cascaded slightly different, right? It's inside the create store instead of outside and inside that function. By the way, notice we still call create store with open close parentheses. That's an important thing that I wanted to note. Notice here, when we call create store, see that this right here, right there? You have to call the function without a factory function inside of it. And then from there, you get back essentially a store API that's a function itself, and you make a call here. So it's almost like you can think of it as an IFI almost, right? You're defining something. It's a function that returns a function that you then call. Okay. So that's a slight gotcha, but at least it's consistent. So now we have these calls here, and then for React, we actually have to create a custom hook. All right. So this is a custom React hook that's internally calling use store. All right. This is a Zustand hook. I'm passing in my store instance and then what's called a selector. And we're going to talk about that selector in just a moment. So we're using a Zustand hook, and we're calling with the store instance I just created up above. And then I wrap all that in a custom hook that I want, which is called use app store. All right. So inside our components, let's look at this one here. So this guy here, use app store for the welcome, right? So this is not the welcome with the selector. This is the welcome here. I call use app store, and it gives me back the state and the API. All right. And at any time, right now we're using Spanish, I could say use English. If I click use English, that's going to make a call here to update lang, and it's going to say, hey, add this parameter, which is the language is going to be EN, all right? But if I make changes to the store here, then this should also update. Okay, that's cool, it did, right? If I go back to Spanish, it updated. If I change the UUID here, right? Let's clear all parameters. So now let's go back to Spanish and let's clear parameters. So we're back to English. So I cleared parameters, which did a reset back to English. If I call set UID, changed it here, but not here. Well, why didn't it change it here? And the answer is that we're still calling use app store, but now we're passing in a selector, which is essentially a way of saying, I want to select a slice or a portion of the data only, of the state. I don't want all the state. In this case, I'm only interested in the current language setting. So whenever the language setting changes, then this hook should refire. That's what this is saying, essentially, all right? So that means if I change Spanish, this hook will re-render. But if I change the, let's go here. If I change the UUID only, this component should not re-render because the with selector component here is using a selector. So here, set UUID, and this one does not re-render. You could prove it if you'd like. The really cool thing, by the way, before I use Zustand Store, trying to do this manually and saving all these things to the local storage and trying to make them immutable and all this was, and sharing it between components was a nightmare. In fact, it was buggy as hell. So with the store, it's easy and trivial. But here's the best part of all. In the store, I wrote a function that can synchronize the URL to the store. Because what I want is anytime the URL changes here, so let's come into here. Let's call it 99999, and I reload it. I want the URL values to be used to set some state here. And if I change the UUID back, I want the URL to be updated and synchronized. And if I use Spanish here, then the URL says Spanish and the store says Spanish. And if I went to look at the local storage, I'd see that Spanish has also been saved in the local storage. And in fact, if I come in here, let's just try this, okay? Like, let's do 555, right? If I refresh, now let's clear all these. Let's load it from blank, right? From without any parameters. It's going to look in local storage and see that I had the settings in local storage and restore those and use them, just like we saw in the Angular application. So what's the beauty of this here? That the Zustand Store can be used within Angular and React, be used with middleware, be used with computed properties, and have all these powerful features to do amazing things in either platform. All right, that's it for today's session. Thanks for everyone for joining us. Next time, we'll get back together and we're going to talk about reactive stores using ELF. Zustand is incredibly powerful. What it doesn't really solve, though, are the problems if you want paginated data, right? And what we didn't show here was how we could do some prefetching and caching of the data. And I argue that Zustand is incredibly powerful, but it's not worth the pain of trying to put in support for pagination or paginated data, where ELF does that really well for us. Plus, I want to demonstrate to everyone another approach to reactive stores. So today's session was on Zustand stores. Next session will be on reactive stores with ELF. And I'd like to give my thanks again to Jason for joining us and helping me write some code. Thanks, Jason.
Thank you, Thomas.
All right. See you, everybody.